So we're back. 14 participants. So we scared everybody off. So my apologies if this was hard. I sent around a revised code because it's often the case in GAMS, you like to write down the logic, but you have to be a little bit careful of what happens if you don't have, if something is missing. And one of the things in this data set I gave you is there's one region which has no supply. So you have to be a little bit careful for keeping track, because there's no activity in that region. It's not always the case that you need to suppress stuff, but I'll just show you in the code I sent around how I modified this. So I gotta go to share my screen. I can't really, I'm kind of flying blind. How many, do I have people actually on board? Am I? Okay, that's right. So if I look at simple sanctions.gms, so this has got the original sort of data set with a random data set. And then I put in here, this is again, just a GAMS programming thing, is I put in a label called random. And so I can say, go to G20, and then I go down here and I can say, rather than be random, I can say label a G20. So that way I can put in the data for the G20 model. If I look at where this is, the data file looks like this. That's their G20 data set. So this guy, I currently have random elasticities, but I think what I'll do is I'm gonna just basically, let's just leave those like that for now. And then we'll go down here and I'll say, what do I need to have? I need to have D0. So I have to have here, so assign. And I have X0 is now this table. And I'm going to put in 2 parameters here to use the other data set. I'll say parameters D0 and Y0. And so D0 is the reference demand, which has got to be D0 of R is going to be the sum over RR of X0 of RR to R. So that's saying the demand is whatever the supply is. So because if X0 is given, then I know D0. And the same thing, then Y0 of R is the sum over RR of X0 of R to RR. So I've completed the model with those 2 guys. So I have elasticities, I have a benchmark values. Now, the one change I made in this other one was to put in a set. So declare this is going to be the set of regions with non-zero oil supply. And so that's going to be, you could say either equal to that value or is equal to yes, such that Y0 is greater than 0. And so you could say that'd be, if you want to be completely literal about it, you could say I want R to be in RY if Y0 is greater than 0. That gives me a set that identifies which ones are not 0. And then once I have that set, then I can go through my model and I can say, I'm only going to turn on equations for the regions which have non-zero supply. So for example, the supply function, I don't need to have that for ones that are already 0. Because if there's no supply, then there's no C. If C is not defined, then exactly what is that equation defining? It's not, so that way I have it only for the regions that have RY. There's demand in this data set, there's demand in all regions, but the supply is limited. So therefore I say the output market constraint that says Y of R is going to be the sum over regions RR of exports from R to RR. That equation only goes in for those that have production. And then I'm going to say, well, I want to keep track of what flows there are in the model. And so now this is the flow will be X of R to RR is going to be the reference demand. I'm sorry, this guy can be just simply, I can just call this X0 of R. Oh no, I'm sorry. That's going to be demand of RR times the benchmark is the amount theta times d var is equal to x0. But I want to have, as d goes up or down, I want to have export trade flows respond to what happens to demand. And then I have the substitution. So there's two factors going on. One is changes in aggregate demand, D0 go up and down, and then also there's substitution across what the sources come from. So that's my CES demand function. And then finally, I have this price index refined oil in the absence of, I'm not keeping track of other components of cost other than crude oil inputs. And so therefore, the price of oil products in region R depends on the prices of the oil in the other regions RR and the taxes that apply on shipments from RR to R. So that's this basically the CES function. I go to my lecture notes. Yeah, so this guy, and I have a mistake in the lecture notes. That export should not be X bar. That should be, I'm sorry, I made a mistake. So that there's an error in the logic because this guy, we have to have the demand response here as well. So that's not, so I need to fix this. I'll fix it and I'll fix it at lunchtime. Okay, so there's the price, and then I solve for a benchmark. So this is going to be check, verify. That's the benchmark replication. I've set t dot fix equal to 0. So all the taxes are set to 0. That's got to be calibrated. And then once I've done that, that's the equilibrium model, which is a complementarity problem. And then I declare one more equation, which is going to represent what the value is of sales from the target region, which is C of R times Y of R. And that's going to be my objective function. And then I declare a model that's got all the equations in it, including that includes the OBJ def and all the other regions. And then I'm going to say, okay, I want to minimize what the value is of their earnings, and the instruments I want to permit to be variable in the model are going to be all of the taxes on the imports from the target region to the coalition regions. So I'm assuming that they can tax oil inputs. So that's and so then I say solve this using nonlinear programming. Once I've done that, then I can do some reporting. And so this is report writing. Optimal point. So first of all, I'm going to say, what are the percentage changes? Say, well, I want to know percentage changes in price, and the purchase price of products. I want to know changes in the value of sales. I want to know changes in the price of output. I want to know changes in the delivered price from the target region. So that's the purchase price from our target to all of the regions R. I want to say what happens to the demand for oil products by region. So there I percentage change is going to be D divided by D naught. And there's percentage change in the level produced. And finally, I have percentage change in the bilateral trade flows. So this is just looking at all of these guys. I just assigned this guy to 0 for all. For all flows, for bilateral flows, which don't. That's this assignment, and then I do the percentage there. And then I say, here I'm going to say round to the nearest a tenth of a percent. And then I look at the changes in producer and consumer surplus. Looks like that. And then let's just see what we get coming back. Typical thing, I make errors always. Oh, I forgot the theta I didn't get. I hadn't defined this guy. What am I doing there? Unknown simple. How can theta not be known? Let me just see here. Let me just go. I screwed up. This is bad. I'm myself. Okay, so let's just go in there. Say theta. Oh, in the G20 data set, I didn't have this. So this would be, so D of R. So let me just replace this by just the demand index that represents P of R minus epsilon. Oh, wait a minute. No, I'm sorry. All right, so I'm theta. So theta. So this guy, I have to define this one down below. So I'm going to say theta of R is equal to x0. So the fraction of imports that come from this guy divide d0 of RR. So that gives me this guy. Oh, wait a minute. D0 goes here. Maybe it's easier to do it. Yeah, I need the value share. So the theta, if I go back to my CES equation for the price index, I'm using, in the price index, I'm using this expression that's this calibrated share form. So theta of R prime to R is the value share at the benchmark of R prime in R. And so I'm using that, and this guy's with a C0 equal to 1. So this calibrates to a price of equal to 1 at the benchmark point. So that should be correct. Let's just double check that this guy runs. Two errors. I'm very close. Meant not to screw this up. Simple sanctions. Oh, my error here. R target. Sorry, guys. Declare that as a singleton. So that then solves the model. Now, the reason I did that as a singleton is just, if you do as a singleton, then you can say R in my reporting, I can run it with so it says that says what's the price of oil from the target region in region R. So so here, this is in GAMS. Normally you want to control all the sets on the left-hand side, but if we want our target to be a single region where we change it between being R1 or RUS, then we declare this as singleton. So this gives us a model. If I look at the output from this model, why does this guy not go away and stay away? I say Alt Shift, Control Alt Shift H. Control Alt Shift. This is really annoying. I wish I don't. Okay, so that guy, if I then look at let's look at the answer what we get back from this. Simple sanctions. So now we have percentage changes. And if I look at this, I've got, can't I get this guy to go away? Please go away. Okay. So I've got, this shows what happens to trade flows. So essentially what this shows is that as we tax Russian exports to the OECD countries, we can see that the optimal policy drives the imports into France and Germany down by 99%, nearly to zero, but not exactly. And then if I look at what happens to USA, let me say set font. If I look at, so now from Russia, I'm just going to open this up so we can see this. It says almost all of them have demand's going down by almost 100% in the countries that are in the coalition. I don't know, where'd the US go here? USA goes down to 99.6. They all go down by a lot. And Indonesia goes up by 93%. So that shows that you can see along this row right here tells us what happens to Russian trade, right? To Russian exports. And you can see then in the countries that are binding. So what we're interested in is understanding what drives those things, right? So what drives the degree of when do you not want to abate as much, right? So we'd like to be able to control the elasticities and see how that depends. If I then look at what's happening to exports, for example, for Saudi Arabia, this shows a major realignment. The Saudi Arabian exports, so Saudi Arabia has a large increase in its overall supply. If I look at the overall Saudi Arabian production goes up by 2.3% with that elasticity. So if I look over on the right-hand side, you can see what happens to production. And so we have small changes going on in some countries, 3.3% down in the Russian case, other ones. So what I'd like to do, so this is a model where we can do a simulation. We can ask the model, what's the optimal policy? But what we don't know is how does this depend on the elasticity structure? We'd like to know, okay, what do we expect to be plausible? And that's, my intention is less, I didn't spend a lot of time researching the literature on this calculation. I just thought, okay, this is a nice little calculation to do. So I imagine there probably is literature on optimal sanctions. We worked on this actually during the Crimean invasion. We worked on this, but in this case, all I'm mainly interested in is how do we determine the sensitivity of this with respect to a few key parameters, right? And so for that purpose, I'm a big fan of using GAMs together with pivot tables to look at results. It makes it very easy to pivot through results and look at stuff if you get it organized so you can basically generate the simulations and dump the stuff out. So, and there's essentially, so the first thing when you're, and let me just go back to my lecture note. The next thing I'm going to say is, so this is what we want to do, Control, Alt. So if, why is this guy not, how do I get, it's, I wish it had more response. So what are the programming constructs for doing sensitivity analysis? So that's the, how do we make this sort of operate? And I propose first that we just, of course, we want to represent here, ADA represents the supply response. Do we expect other countries to step in and increase supply or not? So those are probably assumptions that you want to tailor to the region. But let's do a sensitivity analysis over 3 key parameters where we hold them the same across all regions. So the parameters will be epsilon, which is the price elasticity demand for oil, right, in all regions. Eta, which is the price elasticity of supply for oil. And sigma, which is the elasticity of substitution of where the oil comes from. So those are the 3 parameters. Of course, all those could depend on different markets. And certainly on the supply response, that's something that probably you want to say, well, the Saudis have already declared they're not going to step in to increase supply. So you might want to put the elasticity lower so you could craft this. But initially, let's just get a feeling for how these 3 parameters drive things. It's more about the programming than it is about anything else. So the first thing is, notice here that I have epsilon equals percent epsilon percent. The percent epsilon percent in GAMS is a string substitution for an environment variable called epsilon. Okay, and the reason we do that is that this then we can assign default values for these environment variables by saying if not set epsilon 0.2. That will assign a value. The default assignments need to come before the use of the variable, but basically you can see what the basic structure is here. I can set a default value, and then I can set up a bunch of solves on the command line or in a separate GAMS program to generate a bunch of different solves, and then I can pull all the solution values together and stick them into a pivot table, right? So this is where, if I think about, if you're just getting started with GAMS, this is where in a GAMS team that does modeling work together, typically there's somebody who's really good at looking at results, There's someone else who focuses on getting the model working and making sure that makes sense. And there's someone else who's paying attention to policy and what the writing is that's required. So all three of these are very important tasks, right? This thing of generate results and look at them, that's where modelers tend to be bad at that. Once they get the model running, it's like, okay, I'm done. But in fact, that's really where the work starts, is you have to be able to run the thing. So what I'm showing you now is what would be the main task of the person whose job it is to take a model that's operational and to run it, to figure out what's going on. So I'm going to show you how I would set that up. So let's do it first the simplest way. So we're going to go into our model. So there's the model we have. Let's say simple sanctions. I'm going to say write this guy to be model.gms. So that's going to be my model. Originally, I was working on, let's see, the percentage change. I'm going to drop the surplus calculation because I don't want to do too much stuff. So you could also calculate consumer and producer surplus changes in this model as well. It's actually, in terms of a model, it's got lots of stuff. I'm going to remove the stuff about jumping around. So I'm just going to go to G20, and so now I have the simplest possible model. It's got the G20 regions. Remove the assignment statement. Okay, so we're going to say here, it's going to say, down here, I'm going to say, if not set epsilon 0.1. And one thing in this model is that this is a static model. And that's not to say we can't model the dynamic response, but we're not trying to here. So this is a short run effect. You could do a nice little putty clay model where it takes time for demand to respond, and you could have things change over time, but let's not worry about that right now. So say if not set eta, let's say it's 0.5 initially. So now I've assigned a default value for eta, for epsilon, and I say if not set sigma, set sigma 4. So now I've got a substitution elasticity, a supply response, demand response. I'm assuming uniform across all places because we're just trying to understand what drives the main results. Now here previously I just put in random values. So now I'm going to put in epsilon, so they all have the same value. This be eta. Sigma. So now, as I've done it here, I've just made that pretty. So now I've just assigned values, the same value in all regions. And what it does there is a simple string substitution. When they did the string substitution, this environment variable feature in GAMS, they decided to keep it equivalent, identical to the way string substitutions work in batch files. So it's exactly like the rules follow batch files. One confusing point about that is this is case sensitive because environment variables in batch files are case sensitive. So this is one place where GAMS is case sensitive. Okay, so that gives us this stuff. And I like to just make one change at a time. So I'm just going to save that thing called model. I'm going to say GAMS model just to verify the thing solves. There I get a solution. You can see it's not a very big model. This is a simple thing to solve. So now once I've got that running, I'm just going to double check my results to make sure they look okay. And now I can see what I've got. I've got here, this is 15%. German production goes up by 15%. Italian production goes up by 6.5%. Russian production goes down by 8%. So I can see immediately the elasticities do matter, and the random ones I picked were different. So here you have a different result. And we can see here, oh, the C Rus looks like it's not, doesn't make sense. So let me just see what's happening there. C Rus. That looks like, okay, no, it's actually a lot. So if I look at what's going on, that's correct. What it says is the price, C Rus says the price of Russian oil goes up by 300%. So it's actually a big amount. And what now is happening to exports? So here, if I look at what's happening to Russian exports, they're essentially going down by almost 100%, not exactly. And Chinese imports go up by like 104%. Indian imports go up by 140%, right? So that's Indonesia by 128%. So now I've got the model running. Now let me do some changes here. I'm going to say, and I'm just going to do this by hand. You could do this more fancy ways, but I'm just going to make a batch file called run.bat. I'm going to say GAMS model. And if I look at what it's going to be epsilon equal to 0.1, epsilon eta equal to 1, sigma equal to 4. Eta was equal to 0.5. And eta is equal to 2. So I'm changing the eta, holding the other guys the same. So I hold epsilon and sigma equal to the reference value, and I change eta to four different values. And then I do the same thing for epsilon. So this guy is going to be, eta is going to be equal to, oh, wait a minute, this should be 0.25. 0.25, oh, because I made a mistake. Okay, so that's the same. So this guy goes like this, and I just need to have, so this guy eta is equal to 0.25. Now I want to, basically now I'm going to just do piecemeal sensitivity analysis for these guys. I'm going to say this guy eta is equal to 2, and eta is equal to 8, or sigma equal to 2, and sigma equal to 8. I go down here and I'm going to say this guy is equal to 4, and this guy will be equal to 0.1 was the elasticity, 0.2, 0.5. So this guy, maybe we should make the default one be 0.2. That way we can have 3 values. This would be 2, 2. This guy would be 1. So now I've got the model set up to run a bunch of different cases, right? And this is I'll put a note in here. This is going to be piecemeal sensitivity. Right? So that gives me a set of values. And now I'm going to say here, run. And all I'm just doing here is I'm just verifying that I can solve the model. Now, here we don't have, the model is small enough that we don't have a problem. If I were working with a bigger model with lots of sectors and so forth, then first thing I would do is build an aggregate version of the model, because I want to protect my time. I don't want to be waiting for a long time. I want to make sure I get, because the beauty of the GAMS programming environment is that once you get it running in the smaller one, then it's easy to expand the size and let it run. So you get something running small and then you go fast. This one, I don't have to worry about that because it's all pretty quick. So it's going to be, so here, this guy is going to be the reference case. So now I verify they all run, but when I run it, they overwrite. They each write model.lst on top of the other one. So I've not saved the results. So now I'm going to say here, I'm going to say GDX equals ref. That's the reference case. And then I'm going to call this one GDX equals high eta. This guy's GDX. Oh, I'm sorry. This is going to be low eta. It's going to be ref. It's going to be high eta. This is going to be low sigma. This is going to be high sigma. It's going to be low epsilon, high epsilon. Right? So I've generated GDX files that go with each of them. Right? So that's just all I've done. And now this is again, I'm again showing my age, and so I'm being in the batch files. Just run the batch file. The beauty of the batch file is that you can go back and see exactly what you write. Now, if you're trying to write code that can port between a Windows and an Apple machine, you're better off to take these guys and have it be put in a dollar call like this for each of these guys. So if I do it like that, and then I put in a comments, and then I call this guy run.gms. That way I have a GAMS program that calls GAMS. And this same program works on an Apple as well as a Windows machine. If you just work on Windows machines, if you're like me, then you're sort of, I'd rather just use a batch file. So whatever you want to do is fine. Okay. So the final thing I would do here, and again, this is just, again, I'm old, so it's like, this is just, when I went to Norway in 1982, I had spent a year working at Margaret Jacks Hall at Stanford, and that's where all the computer science guys were inventing Unix, doing all this stuff. And I used to go in, the computer science guys would come in at midnight and they'd play bridge for 2 hours and then they'd start programming, right? So I found that the engineers were short hitters that have to go home around 10. And so the period from about 10 to 2 was the point was the optimal time. But occasionally these guys would sit down and I'd look over their shoulders and I'd watch them program, and they were just amazing. And at this time, you have to understand, this is a lot of stuff hadn't been invented at that time. So the idea, this guy, Richard Stallman, was this MIT professor who had invented this language called Lisp, and they wrote this text editor in Lisp called Emacs. And it was just like, it was like magic. It was like watching magic, how these guys work. So when I got to Norway, the first thing I said to Lars Mathisen was, I hope you don't mind, I want to take a month just to work on learning Emacs. I ended up spending 2 weeks, but I basically did nothing but work on learning how to use this editor because I had seen guys use it and I thought, man, that's really powerful. And I basically never looked back. I spent this time. These days, there's lots of other tools around. Although I was sorry to see that the Atom editor has been rescinded now, right? Atom has been, Microsoft bought GitHub and decided to move it away. So Atom was a pretty good, there's another one of Visual Studio Code people use, but I'm a big fan with GAMS. If you use the GAMS Studio, that's a good environment, but there are limits on how fast it goes, and further on how fast you can, there are limits on what you're able to do with it. And it also doesn't port between different platforms. Whereas here, the cool thing is I can use the same editor for using GAMS as well as for using LaTeX, as well as for writing JavaScript, as well as so just using one program for everything. So I'm a big fan of just learning one professional editor, particularly if you're under 30 or under 40, this is a no-brainer. I think that, that you save a ton amount of time. So one example, just to show you, it's look on no hands. I say Control X, left parenthesis, go to the end of the line, delete a word, take a space, O equals .lst, go to the next line, and then it does all of them, right? So you basically, when you use a programming editor, you can write a script that does stuff. So even if you have like 20 million cases to do it, it does it as fast as if you're a script. So a good editor can do things really fast. So now I've saved them as GDX files and I've put them all out on the, so now if I say run, oops, I didn't mean to do that. This is called, I want to say GAMS run. So GAMS run then will run each one of these guys. And it'll work on all of them. And then if I look at what I've got there, I've got, if I do a directory now of startup GDX, I've got all of my results. This is what I call a piecemeal sensitivity. I've done look at all combinations, but I'm looking at what is contributed from each parameter. My recommendation is always to do piecemeal analysis first and then figure out. If you want to vary two things at once or multiple things at once, then do that later. Because when you get all combinations, it starts to get a little bit heavier. So now I have generated GDX files, and if I look at my list files, I have the list files. I'm a big fan when I run lots of cases, keep the list files. They take up space, but that way if something funny shows up, you can go back and look to see what happened, right? You can go back and search through. Because that was just, all that did was all the calls. If I look at run.gms, run just has that stuff in there. And because it's a dollar call, it doesn't even show up in the list file. So it's just like it's a batch, it's a script. So that's the first thing, is that, okay, if we think about how do we control a GAMS program as a user, the first thing just to recap how this worked, the first thing that we do is we put in environment variables, define environment variables. Which can be used for a sensitivity analysis. Right? So I declare those. I make assignments. So on the first pass, assume all same elasticities. So that gives me those guys, those three. Okay, so now I have a thing defined. If I go back now, I'm going to go back to my run.gms. And I'm going to say, now I'm going to say label merge. In GAMS, you can write in a label in the program that gives you a way that you can jump there. And that way I don't have to go through the solve again. I can say go to merge. And now I'm just going to do it by hand. I'm going to say call GDX merge. And I'm going to say ref.gdx, low eta.gdx, high eta.gdx, low sigma.gdx, high sigma.gdx, low epsilon.gdx, high epsilon. Right? So I merged those guys together, and that guy is going to produce a thing called merged.gdx. So let's just go. This is a cheap thing to do, and so let's just see what happens when we do this. Oh, this guy's got to go away. I don't like this, how long it takes for the little button to go away. It's annoying. And there you can see it merged them. So it's going to say call GDX merge. It grabs all these guys get merged. And if I look at directory merged, merge.gdx is there. If I look at the other all the GDX files that are here, I've got, these guys are all 44, and then merged is 295. Now I could say GAMS, what's it called? It's GAMS Studio merged.gdx. How do I call GAMS Studio? I don't know what it is. You can open it in Studio. I'm just using merge GDX because I don't know how to load Studio. So now if I look, whoops. Let's see what sets I've got in here. All the symbols that were in model.gms are in here. And each of them has an index on it. If I look at D, the first index it tells me is going to be the name of the file. So when you do a merge, it adds a label onto everything in the parameter in the thing that tells the name of the file. So that's the reason the names I use for the files are the names that will show up as the keys in my pivot table. So if I have that, then I can say, okay, well, PCT, there's the percentage change. And I can go move this up here, and I can look over here, and that gives me, there's my data coming back. I can pick which one I look at, and I see all the values are there, right? So that's like, I'm sort of pivoting through. So let's now go back to run.gms. And now I'm going to use the tool that Jim used yesterday. Call GDX XRW, inputs equals merged.gdx, output equals pivot report, par equals PCT, range equals pivot data, A2, CDIM is equal to 0. So that's the thing, it's going to move. So move parameter PCT from the merged data file into an Excel file, worksheet named pivot data with no labels on the columns. So that's basically the syntax. You know, I agree with Jim. And there's going to be, GAMS always is developing new tools for moving data across, and there's a brand new one that just came out called GAMS transfer, which is even better than this. So this stuff moves around a little bit, but this guy, the other way to do this is to move it from the GDX file into a CSV file, and then you can load the CSV file into Excel. When you work with large models, when we worked on Brexit, we had report files that were typically 40 megabytes. And so you couldn't load this into a single spreadsheet because they were too long. But if you use the Excel data model, you can move that from a CSV file. So the stuff I'm showing you here is just basically, fundamentally, this is data science chops, how to work with data that's big. And the key thing I find is Excel, what's nice is that you can move over to using the data model, and then you're no longer restricted by the number of rows. Here, I'm going to just use it like this because it's easy to see what's happening. So if I'm going to say here, it's going to be, so then I'm going to say GAMS run, just close up some windows here, close these guys. What else do I have to get close? I don't need GAMS ID anymore. Sam sent me some stuff that's interesting. Discard changes. Just getting rid of stuff, sorry. Okay, so now if I go back and run again, GAMS run, it runs the file, and then I run this, and you can see GDX XRW gets called. I can see first I can see everything got merged. It reads the files, all merges complete, 7 input files merged. And then it says GDX XRW input equals merge.gbx, output is equal to pivot data. Parameter is PCT is what we want to move. The range I want to move it to is in a spreadsheet called pivot data, beginning in cell A2, because I need the first column for keeping track of what the identifiers are. And then it goes out like that. And so pivot report, if I then start pivot report.xlsx, then that gives me the thing. So this is going to be the scenario. This is going to be the region. There's the item, and that's the value. So all I've done is just use the first row to label those guys. And I oftentimes work with co-authors that all they do is work from this point right here. I do a little modeling, send this file out, and with models, I work on stuff where I don't want to take the time to look through all the details. So this is a way you can leverage someone who's a good modeler in your team. They can just work on getting the model operational and let someone else be assigned to running the pivot tables and figure out where there are problems in the model, right? So this is the most efficient way to do this, to get somebody up the learning curve on the modeling and have someone else be comfortable with sorting through. Having someone do the modeling and all the programming and do all the data work to look at what's going on, this is asking a lot. This is actually hard because I find it's a different set of the skill to getting the model operational and checking that things work. That's one set of skills, and then you have this work that requires lots of attention to detail. And so this attention to detail comes at this stage. So I'm going to say here it's going to be insert, and here just the way I would do it. Again, this is not stuff I can teach you. I'm just going to do it. I say insert. I put in labels. I say insert files. I grab the value. I put it into this thing. I say, well, let's look across regions of what happens. Let's look at the scenario being over here. Let's pick the item being like this. And then I can say design, move the chart. I can move it out to a separate file. This could be my pivot chart. Item could be, let's look at what happens to, let's just first look at what happens to production. It's going to be Y. So item would be Y. If I look at and that's across scenarios. I could say sort these guys descending by sum of value, and then I could say, okay, I can go over here and say more options descending by sum of value. So that way I could get a sense about which regions have the biggest. So here you immediately get a visual that tells you what's happening across the different scenarios, and you get the ranking now. See that this is descending, so therefore the low sigma gives you the highest response. So that's the Armington elasticity gives you the highest leverage on production response, and this shows you what's happening. I can move these guys. Format axis. I could say labels low. Okay, so then that gives you the supply response, and that way you have a way, a leverage. And now you're just in the data science world. You're in the pivot table world. You're trying to figure out what's going on, and then there's always this back and forth. And again, that's the reason I tend to have Excel, and then the key command stroke I use is like Alt Tab, and I can jump over and say, well, I wonder what's going on there. And I say, okay, well, let me look at the listing file. What's the listing file say for this guy? And I can go down to the bottom of this, and I can look at the listing. I may find something funny that's going on. I can dig through. And so you basically go back and forth between looking at the results, formatting the output. And what's very good about this format, this approach, is that if I find a bug in the model, then everything's scripted. I just say file save, file exit. You need to close the file first, because otherwise it won't let you run to it. And then I go back and, oh, whoops, I found a bug. I want to rerun stuff. I can go back and say, okay, well, let's rerun it. I just removed the jump that jumps to reporting. And then it reruns everything, merges everything, moves the stuff back in there. And then it doesn't overwrite the pivot table. You just say refresh the pivot table, and all the data is sitting there waiting for you. So it's really this process of using a model is very familiar if you're in the process of working with data on a regular basis. Just you have to think about what data you want to generate, and then how you want to look at it and how to slice it. But this process of like, what scenarios do I want to run? How do I compare them? What labels do I put? That's all stuff that you can do. Are there any questions at this point on stuff? I imagine I've gone too fast or too slow or whatever. I don't. Yeah. Okay. Okay.
Professor Tom, I have one question. I think it might be my version of the GAMS. I have a pretty old version of GAMS. This singlet, and there are one line. I had problem running the one line there you had in the code earlier. So there were the target R, that line, percentage. So otherwise I was able to compute the run that you had.
Yeah.
If this is
there we go.
If this is too much, let's leave it. So I understand.
Kashab, nice to see you.
Yeah, very nice to see you. Yeah, it was so really. I mean, so there has been so much development. So I need to catch up on this one. Some of the things more and the other reporting issue that you did. I mean, so this is quite new stuff, very interesting. I have not done this.
Yeah, I mean, this has evolved over the years. My interest in using Excel this way took a big leap forward when they introduced a data model. Prior to that, I found it incredibly annoying because you could dump the data out. Then when you ran into whatever the limit was very low actually at one point. And now the limit is like 1.2 million records, but even that you hit quickly with a big model. So now that we have the CSV file, so maybe I'll show you how to get the CSV file into Excel. That'd be helpful.
Yeah, okay, thank you.
So here I'm going to say, and now I have to admit that I don't memorize stuff. I just remember that I know how to do, that I've been able to do this before, but I don't. So I'm going to say, I'm going to go out, and this is typically the way I would work. I go to the command line and I say, I know that it's GDX dump is the name of the routine. And all of the command line routines and GAMs for doing this sort of stuff, I'll give you all the options are given on the command line. You just type the command and it tells you what the options are. So what I do is I open a window, I type the command, I get the list. I go to that window, hit Control A and then Control C, and then I go back to my editor and I go to a temporary file. And now I've got a temporary file that has all the commands in it. Now I can do the reading for what the commands are. Again, I'm just using my editor. I go get the commands, I stick them in a file, I can read the thing. I don't memorize the stuff. I think you do it the same way. Let me just see if I can figure out that.
Yeah, I need to learn that technique that you mentioned. So it should be quite useful. So thank you.
Okay, just see how, if I open Studio, I think I can get this. So I'm going to say File, New. So I want to go over to this directory. So now, let's see, where is this command in GAM Studio for opening the command prompt?
So
Could you mute him? Control T. So now I open the command prompt and then I say, now you probably could dig in through there probably is documentation in there, but I'm an old man and animal. So I would say, I know that the thing I want to do is GDX dump. And then I hit Control A, Control C to grab, I say first, label the whole window. That's the reason you want to open a new window, because you just want the stuff in the one window. And then I go back to here and I do Control V, and that gives me the whole list. I put it in a new window. So now I'm looking at what I want to do. I'm going to say here, so the symbol, I need to tell it what symbol I want to dump. I go back to my thing. Alternatively, move the data into a CSV file, which can be imported into Excel using the Excel data model. So we're going to say GDX dump. It's called merged.gdx. So that's the name of the file. The symbol I want to dump is called PCT. It's going to be the, what's it going to be? I look for CSV. PCT, if I look at model.gms, PCT was what I reported. Okay, so I create a, and again, this is the whole idea. GAMS solve says operate in the database. I get all these solution values back. I could dig through and look at the listing for there, but I'd rather get everything into one thing that I can move it around. So and that's where I'm using a declarative structure for the model definition. I do a procedural structure to say solve it, and then I have procedural assignments that move the data. At that point, after doing the solve, at that point has all been loaded, and then I can move the stuff into the parameter for the report. Right, so it's just like a programming language. It says, declare the model, declare the sets, declare the data, declare the model, solve the model, assign the solution values, dump the stuff out. The PCT file is just sitting there. So if I go now to my symbol is equal to that, I have to remember what this was. So I have to say here it's going to be format, called format. Equals merge.csv. So now all I've done is I've just moved the data into a CSV file. So I'm using the GAMS. I don't, this one's not needed. If I'm going to use CSV, I don't need this GDX XRW, and that will not work on an Apple machine anyway, but I'm still relying on the GX merge. I think that rather than, you could alternatively pull each one of these outputs into a separate CSV file, but I think the GDX merge is nice because it just grabs one thing and throws it all together. So if I go here, let's just see if this guy works. And here again, I just am doing it here. So I just did it there. There's merged. So the one thing I didn't put here, it's telling me, so here I'm looking at merged. And then the one thing I didn't do is I need to put a title on here because I normally when I do this, I also say, let me just see here. Header. Header equal to, it's going to be scenario, region, item, value. I don't think I need descriptions because this is just the data, but I need the header. So now if I go, just verify this works again, what I'm doing is I'm going so now it's giving me the quotes. I don't think I want the quotes around that. So I got to hear, I'm just getting this right. CS, is it double quotes that goes around that? I'm not sure. Let me just triple messing around. More, it's going to be merged CSV. This is something you have to do. Okay, now I got it. So it says you put double quotes around the header, and then it gives you one label for each one. So now if I look at the file, this is the file that gets generated. It's got everything is quoted on the input string, and I put it on a header that's got titles for those guys.
A lot of the data we work with is HS codes, right? And a lot of this start with zeros.
Yep.
And so when we export between, and we bought between CSVs and Excel files, we notice that a lot of them get cut because it won't necessarily categorize something as a string when you import it into Excel. So are these, all the things in the double quotes, are they
GAMS quotes them for you.
strings?
They're all strings, yeah.
Everything in double quotes is strings, right? And so it recognizes the value as a number, it looks like.
Yep.
Yes. Okay. So how do we prevent that? So if I want to say that like all of these HTTPS codes are strings, when I'm putting it between the CSV and the Excel file, and if this is too much of a digression, we can do it later. But
These are things where I'm really good at the interface between GAMS and CSV. I've been around the block many times. Going from CSV to Excel, I don't know that I'm an expert at that.
maybe there is
The thing is that there's the thing, but the data frames in pandas. So the thing is that, but that's where, okay, so if,
I check the data type. If I don't like it, I change it right away before I process anything else. Yeah.
but that's but those types of questions where you want to control things with a finer degree of precision than you get here, then that's where I would look. The GAMS transfer tool is very cool because the GAMS transfer, this is this thing that's just come out in the last month or two, has this ability to give you, it uses pandas for moving the data, and you get very granular control over the formatting of things. This gives you all control that you would get with pandas. So this guy, and the beauty is it's designed to work natively with GAMS. So you get the stuff in the GDX file, and then the move from the GX into the CSV and so forth is all handled control. Going from CSV to Excel, there's going to be a much bigger audience of people that can answer those questions than me, right? Because that's something that everyone's doing.
So maybe I'm asking something up in Excel, right? Even when I switch it back to a string, like variable, those preceding zeros are out already. So maybe I'll just need to look that up or something like that. I just wanted to know if I could do that within GAMS and just have it be that way already.
No,
Okay.
I've never seen that. It's always post process.
Yeah. So I'll go into GAMS transfer, see if I can.
Well, you may be able to do it here though.
With
Insert,
the latest version of GAMS, they came out just 2 weeks ago. They introduced a whole new tool, and it's called Connect. And you need to check that out because that is their new way of handling data transfer in and out of GAMS. And that they will tackle a lot of things there. If you check the release notes from the latest version of GAMS, version 39.1, GAMS Connect is the way to go.
but I'm thinking here that, here I'm saying, so now I'm in a blank spreadsheet. So here's a spreadsheet that's blank. I say, so that's file. I can say data from file, get data from file, from a CSV file. And then I'm going to say, now I go, again, this is the way I work, is I tend to use my editor to get the location. So then I copy the location in there. There's merge dot, and I'm going to say import. So it establishes a connection. And here, I'm not sure whether, I think at this stage, you may be able to modify things at this point in Excel when you do the import, but I'm not sure. To be honest, I know enough about this to get something running, but I haven't spent lots of time working on this. So here I'm going to say load, I load to, and I say only create the connection, add this to the data model. Boom. Then I'm no longer subject to the limitations on the size of the data file. If I load it into a spreadsheet, then I'm limited by the number of rows. Here you can go big, right? And it's similar. And again, Excel, all this stuff, because data is becoming so much more ubiquitous, there's so much more of it. This stuff is changing all the time, right? So these tools, it used to be Power Pivot was the thing before, and now that's gone. And so the stuff is all moving around all the time. And the fact is, you could say, oh shit, this is so annoying, I don't want to mess with this. But the fact is that this getting comfortable with these tools and moving data, this is where you make money, right? In terms of like, if you want to be good at what you're doing, it's like, take the time to think about what. No, but the thing is, in terms of doing stuff efficiently, this is where it all comes down to, right? So there we have this guy. And then if I say, so that shows me the label, I can see the columns. And then I can say, for example, here I can say insert. Again, I do the same trick. And I say, use this existing spreadsheet. And I can say then here, I'm going to say merged. I think you can do that. Yeah, if you send me a file, I think I think I've done it before. It's just been a while, but it's like, anyway. Yeah. So here, so there's the same pivot table I had before, but here now I've pulled it in from the CSV file into there. And so therefore, I didn't need to do it for here, but at least I show you then this is the way you avoid dimensionality constraints. Okay. Okay, so file save. Let's say file name. This will be pivot CSV pivot. So I'm going to give it that name, file, exit. Then I'm going to say GDX dump, and that's merge. So the beauty of this now is that that program is looking at merge.csv. So if I just rerun the file, then you can say refresh my data model, and it'll go and pull the CSV file. The thing is that this is an area where a lot of people are working on this stuff, on these data things all the time. So it's a thing where you can really benefit a lot from being in an environment where there's other people doing the same thing. And my suggestion would be to use the pandas, sort of I think the getting up the learning curve on the scripting language is probably the best way to be good at that. So that guys goes together. So that I've got alternatively moving its use, and that runs like that. Okay, so these guys all look like that. So I'm just going to do one more thing. I have 20 minutes. Unless there are other questions. So this is piecemeal sensitivity analysis. We may alternatively want to run systematic sensitivity analysis. Okay, so systematic means I want to look at all combinations of these guys to run multiple cases, right? So you want to be able to have a pivot table where I have not just the key for the single scenario, but I want to have 3 keys on there because I want to know, I want to be able to vary across all 3 of these guys, right? And that's a case where, again, all I can do is show you how I do it. And I can also warn you that I'm a dinosaur. So it's just, it's a real programmer can write Fortran in any language. So I just do it the same. That's the way, but I'll show you what I do. It's going to say, I'm going to say, search for SSA.gms. SSAgen.gms. I'm going to say this will be titled generate a batch file to run SSAs. Okay, so I'm going to say sets will be epsilon, and this is a new program, so it doesn't know what epsilon is. So I'm going to say the first one will be 0.2, 0.1, 0.5. I'm going to say eta. And again, this is just, I'm showing you how I do this. Eta would be 0.25, 0.5, and 1.0. And then I have sigma. And that's going to be 2, 4, and 8. So now, just a warning there, this is a thing that's a little bit cryptic. I'm declaring this a set. I want the element to be 0.2. If I didn't quote the 0.2, it would think that it was a 2-dimensional set. So you have to quote something that has a dot in it. It's a set element, you have to quote it so it knows it's just 1-dimensional. That's something that's a little bit unusual, but that's just the way it works. So this is the demand elasticity. This is going to be supply elasticity. I'm just doing it so I can, if you take the time to fill in the thing, you'll remember this is the Armington elasticity. Take the time to write some descriptions in where GAMS expects or permits you to write them, then you'll remember what you're doing. I'm going to say loop. I'm going to say file SSA run.bat. I want to, well, okay. Okay,
The
.gms.
batch file runs only on Windows. While the GMS file runs on access level. That is our inside joke.
I spend all my time trying, or we spend all of our time trying to get stuff to run on both systems. So now this is the way I'd write. And again, this is just me. I've been programming GAMS and GAMS a lot. So if you're good at Python, what I'm showing here, you could just write it in Python. So it's really up to you. In GAMS, you'd do it as a loop like this. Well, I mean, it's actually, I think the GAMS program is pretty simple. To put facility as a means of writing a text file. So I say, I want to create a file called SSA run. I want it to be SSA run.gms. I want the label width to be 0. And I'm going to loop over these guys. I'm going to say put. It's going to say call GAMS model epsilon equals epsilon.tl dash dash eta equals eta.tl dash dash sigma equals sigma.tl, right? And then it's going to say, yeah, no, but the thing is now I have to generate a GDX file for this guy, right? Right. So now I have to say GDX equals, and let's call this, let's just, so it's going to be, I want to label this guy. So now I've generated a GX file. I haven't put an output. I've read it. So let's just run this and see what happens if I say GAMS SSA gen, and I say run SSA run MS. Oh, I need to put a slash at the end. Then there is my thing. Oh, and I have a mistake here. So this guy is going to be equal to, I have GDX. Let's just, I'm thinking about how to label these guys. This is always a challenge as to what to label it. But let's call this, just do it this way. This guy's, I didn't, 1 second. So I don't like the labeling. I need to do this. Let's just do it as a SSA gen. Let's just say this. So we have to be a little bit careful because we have these dots in them. So this will be, let's call this like that. And that's going to be, shit, I'm mad at myself. Let's do it this way. Low, let's call all these guys low, ref, high. I'm sorry. That way I don't want to do that much complicated stuff, but let's just use ref high. This will be low, ref, high. That way, otherwise we have dots inside the labels. It gets to be hard to do this. And that's, so I'll have to change, and this will be SSA model. So we'll have a different name in here. So is equal to epsilon.tl eta.tl sigma.tl. So now if I run this guy, SSA run looks like this. So that's, guys, is going to look like this one. So there I have all of my runs. I should probably put an output file on this as well, right? So if I wanted to, and this guy could probably be moved out to, this is equal to 56. So I'll say here. Just going to add this thing. So, and that's got the output file. If I want to, let's see if I move this guy out to 56, move this one out to 72, that'd be better. So it's going to be at 56. What I like about this approach to doing this stuff is it's all systematic. You just are doing one thing at a time and you can see all the calls. You could do something more fancy where you call it in real time from GAMS, but I prefer to write a script that I can see what I'm doing, right? You can see everything and then you can do it all at once. Oh, where's this? Oh yeah, we do. We have to go one more over. So let's move this guy to 60 and move this one to 70, 76. Yeah, so this is my approach is to do it carefully. Now I've got all the results. I've got all the stuff running. I still have to merge the stuff together to get the labels on it. But this guy is okay for doing this. This is okay, right? And maybe we should do is it's actually helpful to say, okay, that's fine. GAMS SSA run. So what happened there? Oh, I'm sorry. It's not keeping model.gms. SSA model.gms. So I had to change because I went to low, medium, high. So I have to basically say this guy is equal to that, and that now I have to say I have to know what the values are. I think I'm going to take a break now, and I'll do is I'll put this together, and systematic sensitivity means you have to generate more runs and you have to basically do some assignments, but I'll produce an example that you can use as a model for that. It's yeah. So we'll pick this up at the beginning, at the end. And I have one response from Sam. There was one example. So what I'd like to do also is to pull in her model as well, and then do it together so we can compare not just across parameter values. If you think about modeling, one of the things I find really kind of intriguing is structural sensitivity, where someone else's data set or someone else's structure may change things. So I'll put this thing together and then show you how it works, pull them together. It's not this systematic sensitivity. There's not it takes a little bit of messing around to get it lined up, but once you get it lined up, typically the way I work is I run one script that generates all the files I need to run, and then I run that file, and then I can pull the stuff together. And one of the things that's nice with large models is that you can use the call statement in or the start statement on a Windows machine. I'm not sure about the Apple, but you can do it so that if you have a machine that has multiple cores, which almost all of us have now, it's very easy to run 8 of them in a row. So you can basically run, if you have many scenarios to run, it's a very simple matter to queue up the model to run lots. But then, so when we come back, I'll go through the SSA example, and then we'll go on to looking at the WiNDC model this afternoon. So that's the plan. We'll look at the vanilla equilibrium model. Okay, any questions from chat? Let me look and see. I've got one question here. Oh yeah, yeah, Eric had that. Okay. So we'll be back at 1 o'clock. Have a good lunch, everybody. We'll talk to you then.